The next test is the earth electrode test. I've incorporated two volunteers here from the college. We've got Eric Brodie and we've got a student, Alex Brodie. Before we go driving any earth electrodes into the ground, we need to check the ground first to see if there's any buried cables, gas pipes, water pipes. So we're going to use the cable avoidance tool. These are the three settings we're going to use. There's the power, radio and generation. We're actually going to just use the power for this one. We can also use the radio detection to see if there's any data cables under the ground, but I very much doubt it. First, to actuate the cable avoidance tool is by moving my hand onto the trigger. This makes a beep. I then hold the detector approximately an inch from the ground, and I move in a straight line across the area that I need to check, moving backwards and forwards. This is actually detecting any cables that are running in this direction. To actually see if there's any cables running in that direction, I need to move the detector 90 degrees and do the same process. As you can see, there's no beeps or bleeps at all, so I'm presuming there are no power cables under this lawn. I'm now going to move across to radio to see if there are any other cables underneath. And there are no data cables or pipes under this lawn. This is the tester we'll be using. We've got it set onto the earth electrode test. My colleagues have a yellow and red lead, and I have a green lead. We're now going to stretch these out approximately 30 metres away from the earth electrode. HE. As you see, we have the earth electrode just placed a couple of inches into the ground at the moment, and the cables are run out in a dead straight line. And as you can see on the tester, we have 665 ohms, which isn't really acceptable, but the earth electrode hasn't been hammered into its full capacity yet, so we should expect that reading to come down. You see we've knocked the earth electrode in approximately 30 centimetres, and the readings are starting to come down now. We're at 462 ohms. Ideally we want this figure to be less than 200 ohms. Getting less and less. We're now in at 70 centimetres, and you can see the value is below the 200 ohms, which we're after. We'll knock the earth electrode as far as we can and see what readings we can get from this soil. $174, that's the lowest we're going to get. Now what I'm going to do now is ask Eric to move the second probe 3 metres away, and we're really going to test the soil conditions at that particular point. So Eric, if you'd like to move it 3 metres away from you now. Okay, we're coming out at 175.9 ohms. If you'd like to bring it back now 3 metres, well 6 metres from where you are now, Eric, back towards me. Okay, and it's coming out approximately the same sort of reading. So we know that the resistance of the ground is constant in those 3 particular points. Having taken the average for the 3 readings that we've taken, we now divide that figure by the residual current device, the RCD, that we're going to install. So we had 175 ohms resistance average. We now times that by the 30 milliamps, which will give us a figure of around about 5 volts at the earth electrode. Remember, the touch voltage is 50 volts, so we're well within the touch voltage range. The figure of 1667 does appear in the regs. This will give you an exact figure of 50 volts at the earth electrode. Not that you'd want an earth electrode to be reading 1667 ohms. Less than 200 ohms is considered acceptable. And that concludes the earth electrode test.